Okay, so nuts and bolts. How does a blockchain work? Let's say we have a database. And this is going to be my sales transactions. Okay, we've already talked about databases. You should be familiar with this. I have order number 1001. The date is 11/11, and the amount is $1,326. Down here, I've got 1002 on 11/12, and this is for 873, 1003, 11/13. This is going to be 426. So I just got some transactions here, no big deal. What a blockchain does is it adds a level of security to the existing data. And this is one example of how it would work. So what happens is, on my first thing, I have something called a hash. A hash is a cryptographic signature. We'll talk about this in just a minute. Basically, I summarize the data using an algorithm to come up with some little code. It's numbers and letters. Okay, it's like a fingerprint. And then down here, I have a previous hash and a new hash. The first record is the first row, so there's no previous hash. My new hash, I have to come up with a number that looks like this. Okay, cryptographic signature. Again, don't worry about what that means. It's just that number is going to reflect this data exactly. Now, in order to get this number, this new hash, I need to solve for x. Because what I'm looking for is I'm looking for a hash value that starts with a certain number of zeros. So not just any random hash number, it has to start with 2 zeros. So I'm going to put in every number starting from 1, 2, 3, 4 until I find a hash value that meets my requirement. We call that the difficulty, meaning the number of zeros that we're looking for. And we solve for x. In this case, the x might be, 126. So this value plus that, plus that, plus that, plus that equals this new hash value. If you want to think of it that way. Now what happens is I go to my next record, 1002. I've got a date, the amount. The previous hash, in this case, was 00AB hashtag 3. Right? I pull that number down from here. I do some sort of calculation. I try and figure out what my hash is going to be. Let's say it is 86. And this gives me a new hash value, which is also going to start with 00. And I'm going to do 003D4X. So I get some new hash value. Come to transaction 3, record 1003, 1113, 426. I bring my previous hash down here, 003D4X. I solve for a new hash. Let's say it's 1326. And that's going to give me 00A45D. Doesn't really matter. So you'll notice that each of these transactions represents a new block in a blockchain. And if I change any one of these values, if any of these values change, this hash is going to break. It's going to change because each piece of data has a unique signature. So if that one breaks, so if I change this amount to 1,300, well, let's say it's 13,260, add some additional value to it. This is going to become a different number, which is going to break this. That's going to break this calculation, which is going to break that, and the rest of the chain breaks from that point where I make an alteration. Okay. So let's look at the process, and I'll give you an example to walk through. So here I have a transaction. Say I'm exchanging 20 bucks. One person is losing 20 bucks, another person is getting 20 bucks. Okay, so the first thing that happens is I need to record the transaction itself. We have to agree on the amount of the contract. Then we're going to validate that transaction, meaning we're going to check that you have money in your account. We're going to check the parties to make sure it's coming from the people who say it's going to be. and so forth. And then we're going to add the transaction to a block. In this table example, each individual line could be a block. In reality, I could put 10 of these transactions in a block and do the same thing. Once I've added those transactions, I add that block to the end of the blockchain. Okay. Somebody's going to figure out this hash value, and they're going to validate it. This is what we call mining. Somebody figures out what that nonce value is to calculate that specific hash. And once it is valid, then the money is actually transferred to the other party. Okay. So do me a favor, open up a new web browser window on your computer, throw it up on the other screen. And the website I would like you to go to is anders.com/blockchain. All right, you see the screen, it's got 3 green little boxes, a bunch of data and so forth. Okay, so this is a simulated blockchain. Notice they're all green. And notice that the previous hash for the first block is 0. Do you see that? It's like a whole bunch of zeros. That's because the first block here, we call this a genesis block. Meaning it's the very first one. It starts the blockchain, the rest of the chain, and so forth. I'm going to add some data. So go ahead in that first block and type in, a limerick, or your favorite lyrics to a song, or this is a random transaction, or type some random keys on your keyboard. It doesn't really matter what. Type in some data. You'll notice that your block has gone from green to red because you've broken it. Good job. Okay. Also notice that there's a nonce value up at the top, right? It's like 11,316 or something like that. Okay, your previous hash is 0. Your new hash has a whole bunch of random numbers and characters. Do you see that? Now, in order for this to be valid, that new hash has to start with 4 zeros. That's your difficulty. Okay, so I need something with 4 zeros, and then I can do a whole bunch of different characters. So click on the mine button and watch what happens to the nonce value. Basically, when you click mine, that nonce value is going to start at 1 and try and do any combination of data until it gets to a cryptographic hash that has 4 zeros at the beginning. You see that? So your new mined block starts with 4 zeros, right? And it's green. Now in your second block, go ahead and type in some random data. And then click mine. Sometimes it takes a second, sometimes it takes a minute, because it has to look at every combination until it finds the answer to this puzzle. Okay, by the way, this is what Bitcoin miners are doing when they spend lots of money on graphics cards. They're trying to do it faster than everyone else because the first person that solves the equation gets Bitcoin as a reward. So when you solve the equation, you are rewarded with Bitcoin, and that's how Bitcoin gets out into the market that you can then spend on stuff or hoard or whatever. Okay, so a couple things to notice. Your previous hash in the new block matches the hash from the first block, right? Pulling that value over. Click mine on the third block, so you've got 3 green blocks again. Give it a second. Okay. If you go back to the second block and just type a space at the end of your data, what happens? They break because look at your hash. Your hash is no longer a valid hash. Okay, so this is how the block is linked together. It's the chain is that hash value that comes from the previous record that's built into calculating the hash for the new one. If you look, okay, click on the tab that says distributed up at the top in the black bar. In this case, here we have 3 copies of the same ledger, right? 3 copies of the same ledger. Go up to the very top, and in the second block, type in some random data. What's going to happen to your block? It broke. What happened to the other 2 blocks? The first block broke, this other 2 are just fine. Interesting. Okay, so of these 3 versions of block number 2, which is true? Which block represents the true transaction? Or which version of this ledger would you trust? The one that's broken or the 2 that are correct? The 2 that are correct, right? Now, because this is a signature, go back up to that top second block that you broke and just delete the value that you typed in there. If you hadn't mined it already, it'll go back to green because your hash value will go back to the original valid hash. So this is why we can quickly detect changes to the blockchain. Because if someone changes, then one version of the ledger is going to be out of sync with the other ledgers. And so we can identify where the manipulation took place. Now, again, this doesn't prevent us from putting bad data in the first place and everybody saying, okay, that bad data is good. We can still have fraud, we can still have errors. We just can't change them after the fact. They can't conceal that fraud afterwards. So if it breaks here, then it breaks for the rest of the chain. Does that make sense? All right. So basically, we have data that we throw in. We're trying to calculate a hash value. And that block includes 4 pieces of data. You've got the previous hash. Okay, we start with that. We add the new data. That's step 2. We solve for x, the nonce. Solve for x. And once we solve for x, we get the new hash, step 4. That's all that's taking place in a blockchain, which is why when we go back up to this table example, all we're doing is we are creating a summary of the data, calculating the new hash, and then linking it to every subsequent block. That's it. It's just a security mechanism to detect changes to the ledger.